Welcome! In this video, we'll be going over a brief introduction to molar mass, what it is, how we use it, and go over a few practice problems. Let's get into it. First of all, we can define molar mass roughly as the mass of 1 mole of a substance in terms of grams per mole. Tying it back to our previous video where we discussed the mole is Avogadro's number of chemical entities. Now, an important relationship to note is that a molar mass of an element is equal to its relative atomic mass. And here I abstracted just something you'd see in the periodic table pertaining to carbon. And here you have the chemical symbol of carbon, and here, this number down at the bottom, is the relative atomic mass of carbon. And as you can see, that's going to be equivalent to the molar mass. And the relative atomic mass is really just approximately the protons plus the neutrons, adding for isotopes and other adjustments as well. But this number is always going to be equal to the molar mass. And if you're looking at an element, the relative atomic mass is going to be equal to the molar mass of the element. So if this were to be oxygen, you would see 15.999 here, and that would be the molar mass of oxygen. Now let's express this relationship in other ways and try to make it more familiar to what we did in the previous video, which was 1 mole of carbon. We know that's now equal to Avogadro's number of carbon atoms, or 6.022 times 10 to the 23 carbon atoms. What we know from here is that this number of carbon atoms is going to be equal, it's going to weigh 12.01 grams. Right, that's the relationship here. 1 mole of carbon is going to weigh this much, this many atoms is going to weigh this much. All right, so this relative atomic mass over here, the relative atomic mass is going to be equal to the molar mass, and that means that 6.022 times 10 to the 23 number of carbon atoms is equal to 12.01 grams. All right, so we looked at it in the terms of elements, but more often than not, you're going to have to calculate the molar mass of particular compounds. And here, I drew out the example of ethanol. This is the chemical formula for ethanol. And the way you find the molar mass of compounds is you take the constituent elements within the compound, you add up those molar masses, and then from there you have the molar mass of the compound. So let's give it, here's an example here. So you have 12.01, and as we expressed earlier, that is the relative atomic mass of carbon. So we're going to use that value over here. And since there's 2 carbons for every 1 molecule of ethanol, so it's subscript 2, we're going to multiply by 2. So this is going to be about 24.02. Here I brought out hydrogen, and hydrogen has a relative atomic mass of 1.01. You can take a periodic table right now. And what you see here is that there's going to be 6 hydrogen atoms per 1 molecule of ethanol. So for that reason, when we calculate the molar mass of the entire compound, we need to factor in 6. So we're going to multiply by 6, so you get 6.06. I won't bother keeping it in color. And then finally, you have the 1 oxygen. And the molar mass of oxygen, depending on your source, is approximately 15.999. And there's only one atom of oxygen per every 1 molecule of ethanol. So for that reason, this is going to be 15.999. Now, if I were to ask you what the molar mass of ethanol was, you'd add up all of these numbers, and finally you would get something like 46.08, and the units are in terms of grams per mole. Awesome. All right, let's do some practice problems. Kyle finds 1.8 times 10 to the 23 atoms of silicon. How much is this in terms of grams? So as usual, try and pause the video, try to see if you can figure this out on your own, but I'll get to solving it right now. Awesome. So you have 1.8 times 10 to the 23 atoms, so that's probably the first thing we should write over here. It's our known quantity, so 1.8 times 10 to the 23, and that is atoms of silicon, which chemical symbol is Si. So what you want to do here is you want to remember the relationship we learned in the last video, where we saw that Avogadro's number was equal to 1 mole. So 6.02 times 10 to the 23 atoms of a particular element is equal to 1 mole of that element. That ratio is very important, and we can use that ratio and put it in terms of silicon to convert the atoms of silicon into the moles of silicon. So let's do that. So here, what we're going to do here is we're going to do the same thing. We're going to go 6.02 times 10 to the 23 atoms is 1 mole. That's the definition of a mole, as we learned in the previous video. And what we can do is we can make it pertain to silicon in this instance. So let's write silicon here because it applies for silicon as well. So now what we have is that these units cancel out per se, and what we have is the moles of silicon. Now what you want to do is get the questions asking for grams of silicon. So the way we can convert from moles to grams of silicon is by using the concept of molar mass as we just learned. So what we can do is look at the periodic table, and on the periodic table you'll find that the molar mass of silicon, or the relative atomic mass of silicon, is going to be equal to this number, but for silicon it's going to be roughly 28.08. Right? That relationship, the relative atomic mass, is equal to molar mass. So we can use that relationship here once again. So you know that per every 1 mole, and this should be E, so silicon. So for every 1 mole of silicon, you're going to have 28.08 grams. That is the relative atomic mass. That is the molar mass, right? So now we have our answer in terms of grams of silicon over here. So you can say the units cancel out here as well. So after all these units cancel out, we have the answer in terms of grams of silicon. And if you were to put it into the calculator, divide this into this, and then multiply by that, you'll get the answer of 8.396. Right? So the answer to the question, Kyle found 1.8 times 10 to 23 atoms of silicon. That is 8.396 grams of silicon. All right, and these little things here are called dimensional analysis, but it's just a fancy way of using these ratios to convert between substances, units of substances. Awesome. Now let's try a second problem, and this one's a bit more tricky. So we're going the opposite direction. We're saying that Tyrone, he's found 80 grams of silver nitrate. So we're asking how many silver ions has he found? All right, so when it comes to this, it's obviously helpful to write the entire formula because it's not an element, it's an entire compound, right? So here we're going to look for the molar mass of the entire molecule, not one of the elements, right? So how do we do this? Well, the first thing you want to do is look at the constituent elements and get their molar mass, and then, well, add them up. So here, silver, if you look on the periodic table, silver will have a molar mass or relative atomic mass of 107.87. And for every 1 silver atom in the molecule, you have 1 molecule. So you only need 1 atom per silver, 1 silver atom per every 1 molecule of silver nitrate. So we're just going to multiply by 1, right? So it's going to be 107.87. The other element you see here is nitrogen, and if you look at the periodic table, nitrogen is molar mass of 14.01, I think. So that's going to be about 14 because you only need 1 nitrogen atom per every 1 molecule. And then finally, you'll have oxygen. And on the periodic table, it's about 15.99. Multiply that by 3 because you need 3 oxygen atoms per every 1 molecule of silver nitrate. And then that's going to give you approximately 48. We'll give or take, just round it up to 16. And then from here, just add these values all up, and you should get a final answer, which would be 169.87. And that's going to be grams per mole because that is the molar mass of this entire silver nitrate compound. All right, so hopefully you see what we did there. We broke it down to its individual elements, added together, and now we have the entire molar mass. Awesome. But we're not done. We need to do the same thing we did here, and now we can just apply this number. All right, so now let's start off with our given quantity, which is about 80 grams. So 80 grams of silver nitrate. So I'm just going to write AgNO3, right? What we can do from here is we can use this relationship that we just used, 169.87, to express this in terms of moles, because we want to find the ions. From moles we can convert to atoms, and from moles we can convert to molecules, and from molecules we can convert to ions. So you want to convert it into moles first, and to do that we can use this relationship. So for every 1 mole is 169.87 grams. So for 1 mole of silver nitrate, you need 169.87 grams of silver nitrate. So the units grams silver nitrates will cancel out over here. So that leaves you now with your answer in terms of moles of silver nitrate. And what you want to do here is that you know that 1 mole of that 1 mole of silver nitrate, 1 mole of silver nitrate is going to have 6.02 times 10 to the 23 molecules, right? That's the relationship we looked at in the last video. All right, so now these units sort of cancel out, as we say. So now you have your answer in terms of this. You have it in terms of molecules of AgNO3, silver nitrate. So in most questions this is enough, but this question asks for how many silver ions we have. So in this instance, it's not necessary you do this final step, but it does help for understanding. It's that for each silver nitrate molecule, there's 1 atom of silver. So we can do a quick relationship here, where 1 molecule of silver nitrate, sorry, let me just move this over, AgNO3 is going to give you 1 ion of silver. So you're multiplying by 1, but it just shows you how we get this relationship. So you get the molecules of AgNO3 canceling out, and finally you get your answer over here. Now this step over here wasn't necessary, but if there was 2 silvers, for example, it would become very important to include that step. So 2 silvers in the chemical formula here. So now if we were to use all of these quantities and do the multiplication, so 80 divided by this, multiplied by this, and multiplied by that, our final answer would be in the ballpark of 2.835 times 10 to the 23 ions of silver. Alright, okay, so thank you for watching this video. In this video we looked over molar masses and how we can use them, what it is, and how we apply them. In the next video we'll be looking at empirical formulas and molecular formulas, so stay tuned for that.